In the preceding topic, we were solving for a limit by factoring. But in other cases with other kinds of functions, we can't use algebra and strategies like factoring, but we can still approach the limit in order to solve for it. So here's an example of a function, sine x divided by x. There's no amount of factoring or algebraic manipulations we can do to this equation to avoid having x in the denominator. And so with x in the denominator, the one spot that we can't calculate this function exactly is at x equals 0, because we'd be dividing by 0. However, even in these situations where we can't use algebra, approaching the limit still does work, so let's do a hands-on code demo to explore that. Right, here's our equation from the slides. So I'm going to call this sine function. So the numerator uses the numpy sine method, and we pass in our x value into that, and then we divide. The denominator is also x. So simple enough to define that function. And just to prove the point, of course, we cannot calculate precisely at 0 because we have a division by 0 error. And specifically, we get an error here about encountering an invalid value, which is that 0. But just as we showed in the last time that we had a hands-on code demo, we can get very close to 0 to determine what the limit of x is as it approaches 0. So, okay, at 0.1, y is equal to 0.998. And at x is equal to 0.001, we're getting pretty darn close to 1 here. I'm starting to feel pretty confident about what the answer is here. But let's do it from the other side as well. So let's approach 0 from the bottom. So here, negative 0.1, all right, kind of close to 1 is the output. And at x equals 0.001, yeah, we're definitely getting super close to y equals 1. So it's become clear here that as we approach the limit of x equals 0, y is equal to 1. And conveniently, again, because we don't have a 0 in our vector x here, we are able to plot out the plot that we had on the slides. It would be a little bit boring if I went through exactly every line of this plot again, but you can go through and figure it out for yourself based on the last time that I explained what was going on to create this plot. And so here at this point here, I've set up the crosshair kind of visualization such that at x equals 0, you can see y is equal to 1 there. There you go. So now you know where algebra isn't able to allow us to find a solution to a limit, we can always rely on approaching that limit to identify the answer.